Environmental DNA in Coral Reefs, an analysis of monitoring biodiversity and ecosystem health, focuses specifically on the use of eDNA in coral reefs. So, coral reefs are among the most diverse ecosystems on the planet, yet they are rapidly declining due to various stressors, including climate change, pollution, and overfishing. Traditional methods for assessing coral reef health often involve time-consuming and invasive sampling of marine life. However, advancements in genetic technology, specifically environmental DNA or eDNA, provide a more efficient and non-invasive alternative for studying coral environments. So, what is eDNA? Well, eDNA is a term that refers to genetic material released by organisms into the environment through various means, including skin cells, mucus, feces, or even exhalation, sometimes even carcasses of species that resided on the reef. Scientists can collect eDNA from environmental samples like water to evaluate the presence of species in different areas without the need for physical sightings or capture. This method is especially valuable for studying marine environments such as coral reefs, where many species are elusive or hard to access. The process typically involves filtering water to capture DNA fragments, followed by DNA extraction and sequencing. Once the genetic material is sequenced, uh, it is compared to reference databases to identify species. This method has a wide array of excuse me, of applications from assessing biodiversity to tracking invasive species, monitoring endangered species, and evaluating overall ecosystem health. So, the application of eDNA in coral reefs is revolutionizing the way scientists monitor these delicate ecosystems. Coral reefs support a vast number of marine species, but their health is often difficult to assess due to the complexity of their environment and the mobility of many reef organisms. Traditional methods such as visual surveys or fishing gear can be very intrusive and can miss some cryptic species, which would leave gaps in the biodiversity data, therefore not giving a holistic picture of what organisms are actually accessing these coral reefs. eDNA provides a more comprehensive approach. For example, eDNA can detect both large and small species, including cryptic organisms like benthic invertebrates and juvenile fish, which might be overlooked in a visual survey because these organisms are not often seen by the naked eye. This allows researchers to create a more accurate and holistic picture of reef ecosystems biodiversity. Moreover, eDNA sampling can be conducted in remote or deep water locations that are otherwise difficult to access, providing a broader coverage of coral reef ecosystems. Additionally, eDNA can be used to monitor the health of coral reefs by detecting early signs of disease or pollution in the state of Florida where we reside, or where I reside. Um, Coral diseases such as white band disease and black band disease can be devastating to reefs, and early detection is critical for timely intervention, and eDNA can actually assist in these early detection. So, several case studies have already demonstrated the potential of eDNA for coral reef monitoring. In a study conducted by Thompson in 2016, eDNA was used to monitor fish communities in coral reefs off the coast of Hawaii. This study highlighted eDNA's ability to detect both common and rare species, thereby improving biodiversity assessments. Another study focused on the detection of invasive species in coral reef ecosystems. Um, Invasive species can outcompete native organisms, leading to shifts in composition and health of the reef. So, here in the state of Florida, one of the most invasive species that we have is the lionfish, and we actually have state and county ordinances that allow us to humanely euthanize these species to protect our coral reefs. In one of these studies, eDNA was used to detect the presence of a specific species of jellyfish, which was a invasive species that could cause significant harm to coral health by increasing nutrient levels. Early detection of such invasive species is vital for conservation efforts and ecosystem management. So, one of the primary benefits of using eDNA is its non-invasive nature. Traditional methods of species monitoring can be harmful or stressful to the ecosystem by using cast nets, the presence of actual divers, which interrupt the reef function. However, eDNA sampling does not require the physical presence of researchers within the habitat, making it a much more ethical and eco-friendly option. Furthermore, eDNA provides a more comprehensive snapshot of biodiversity, allowing researchers to detect a wider range of species than traditional methods. However, there are some challenges to using eDNA in coral reef ecosystems. One key challenge is the potential for contamination of water samples, which could lead to false positives or incorrect identification of species. Careful sample collection and handling are crucial to minimize contamination risks. Additionally, eDNA analysis can sometimes struggle to identify species with incomplete or degraded genetic material, particularly for rare or elusive species. Another challenge is the high cost and complexity of DNA analysis, which requires specialized equipment and expertise. While the technology is advancing, it remains inaccessible for some smaller research organizations or conservation groups that lack the necessary resources. So this is a photo of myself. I actually participated in a study with the Keys Marine Laboratory in regards to some of their marine protected areas, some of their coral reefs. However, despite the challenge, advances in sequencing technology and bioinformatics are making eDNA analysis more accessible and efficient. The development of more robust databases and improved detection techniques will further enhance the accuracy of eDNA-based studies, therefore enabling scientists to detect an even broader range of species in diverse reef environments. In conclusion, eDNA is a very powerful tool for monitoring coral reef ecosystems. Its ability to detect species without disturbing the environment, combined with its efficiency and broad applicability, makes it a very valuable addition to the conservation toolbox. While challenges remain, advancements in technology and methodology will continue to improve the precision and utility of eDNA for coral reef monitoring, offering new insights and biodiversity of these vital ecosystems.